All right, hit enter and I'll do it.
And more importantly,
welcome to the Hackaday Podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 119. Today we're talking about random robot writing, slithering snake shenanigans, and phased array phenomena. We are excited to announce the 2021 Hackaday Prize has begun. It's back again this year with the theme Rethink, Refresh, and Rebuild. Kind of the idea of getting out of lockdown and figuring out what we want the future to look like, which I think is a very cool idea, a very cool thing to ponder this year. It has 5 categories: rethink displays, refresh work from home life, reimagine supportive tech, redefine robots, and reactivate wildcard. That's a lot of R's, Elliot.
What's a reactivate wildcard? I gotta reactivate my wildcards.
I like that one. I think it's great if you have a good idea that doesn't quite fit into one of the others, then you can enter that wildcard, and it's really up to you to explain, like why it matters, why it's important.
I also am a big fan of the displays one. I don't know why. I still really love that ambient displays of information idea. And I've built a couple myself. A lot of them use, colored LEDs, right? A strip of WS2812s in some sort of housing or other. And it's really awesome on one hand.
Well, I think it's really cool to get out of this trap that we're in where everything requires you to pull your phone out and unlock it and stare at the screen. Other things in my mind, I've been geeked out. I'm sure everyone that listens knows about e-paper this year. And so I remember seeing on Hackaday a project where they had a huge e-paper display that was showing front pages of the newspaper. And that was hung on a wall with a bunch of other pictures. And since it doesn't light up or blink or ding or anything like that, it's really only if you look at it that it becomes useful. So I don't know, maybe we've gone too far down in the rabbit hole of this, but yes, I'm also geeked out about this first challenge. I think it's cool this year. There are going to be 50 finalists who each get $500 cash prize. So that helps with any parts that you're ordering. I assume that means 10 from each round, although you'll need to go and read the official rules to verify that, but that makes the most sense to me. But you can also go to prize.supplyframe.com to read that. There is also a page on Hackaday.io that has an area to look at all of the entries so far. Other big news this week for people that are watching the stewardship of Hackaday: Siemens bought SupplyFrame, Hackaday's parent company, on Monday for $700 million, Elliot.
It's $1 million. Oh, wait.
An incredible amount of money, good for SupplyFrame. It's a wonderful benchmark for them. The question in our minds is more selfish, what does this mean for Hackaday? The great news is that Siemens is making a commitment that SupplyFrame will be an independent entity as part of Siemens, and Hackaday is part of SupplyFrame. And so in my talks with all the good folks over at SupplyFrame, it seems like Hackaday is going to go on doing the awesome things that we've always been doing.
Hackaday must live on. I think we were trying to figure out last night, Hackaday is something like 16 and a half, almost 17 years old now. It's lived through previous financial crises. I mean, Hackaday is older than BuzzFeed. It's older than the Huffington Post. It's older than Hackaday must survive.
I certainly hope so. And I think that there's a lot of value in Hackaday, not because Elliot and me or the writers, or I think the wider community is really impressive. I mean, it represents a critical mass of engineering talent that is really skeptical of insincere outreach and wouldn't put up with BS coming from Hackaday. And I think that I'm glad for that, because I feel the same way about insincere outreach. And it's one of the things that means every time I get together with other people that are locked into this community, it's always an interesting time. It's always awesome people from different aspects of life. And I think that given time, Siemens will come to understand and totally embrace that.
Yeah, Hackaday is DIY from the bottom up and from the top down. And there's no space in there for any other things, really. I mean, we're all doing it, and it's y'all's hacks that make Hackaday run.
But enough serious talk, Elliot. Let's have some fun.
What is that sound?
What is that sound?
This is a journey into sound.
What's that sound? What's that sound?
Last week on What's That Sound, it actually went super well. We were surprised that we got as many answers as we did, and I was gobsmacked that we got as many right answers as we did. So this week, I'm going to give you 2 samples, and we're looking for the nickname of this.
Oh, I know what this is. This is what we talked about, right? You got to stop telling me ahead of time because I know what that is.
I know. Have you ever heard the sound in person?
No, I am very familiar with what this sound is, and I've probably heard prior recordings of it.
I will tell you a tale of woe. I have heard this sound in graduate school.
Oh, oof!
And live to tell the tale.
Interesting time, yeah. But don't hint it. People are gonna get it with the hints.
That's all I'm gonna say. That's all I'm gonna say.
All right, so the second ever in existence Hackaday Podcast T-shirt is up for grabs on this one. If you know what that sound was, head over to the show notes, which you'll find at hackaday.com/podcast. Click on the link for the Google form. We're adding a field to this now. So you're going to give us any email address that if you win, we can get contact. Give us either your name or your alias that we can say live on the show if we draw your number. And then tell us what you think that sound is. So we'll put everyone that gets it right into a pool. And then Elliot's 555 randomness timer with an LED on it will somehow pick that number for us. And we'll do it live on the show next week.
Cool. Well, let's go straight into the hacks.
I have to start this show off with another miniature automotive build. I think that this is an incredible piece of artistry. It would be artisan videos if it was over on Reddit. Christina Panos picked up on this and wrote the article, "Tiny DeLorean made from lighters is a total gas." And it is what I would call Bic lighters, although this is not the Bic brand, so this is just a disposable lighter. But think about that clear colored plastic or transparent colored plastic butane lighter that would just be disposable. Somehow the person that's making this, Ankh Creative, manages to take simple tools and cut apart all of the different aspects of it and glue it back together into a perfect little matchbox-sized DeLorean.
That is a crazy bit of work here.
I'm surprised at all of the handwork that goes into this. So really the only advanced tool here is a rotary tool, like a Dremel tool. And it uses not a cutoff wheel, which I'm used to. It uses like the metal saw attachment. I think I have one. I've never used it on anything. And it works really well here. Also, one that I don't have, which is like kind of the shape of your pointer finger, a rotating sanding digit, I guess you would call it, which works very well. Just a sanding block that you would operate with your hand. There's some kind of cool glue application device that has like almost like a pipette, like a long tube that puts super glue on these. And there's a couple places where you see, let's say like the front quarter panel for the driver's side is made first and then glued to another piece of this plastic Bic lighter. The passenger side quarter panel is then, filed and cut into the exact same shape. It's done with just a little bit of super glue and then you can break it apart. But for me, the best part was some kind of buffing wheel for the rotary tools pulled out. And it takes all of this, sanded and scratched and whatever acrylic and really brings that shine back and makes it perfect.
Oh, the coolest tool for me, I don't know if it's one of the ones you were mentioning or not, but there's it's a cylindrical, kind of conical cylindrical shaped piece of wood or something, who knows, with a little bit of sandpaper wrapped around it. And it's stuck onto just a regular DC motor, out of the scrap bin. And I wonder if you mistook that for an actual Dremel tool.
Yeah, I did.
think this is a totally handmade, just fabricated 24-volt, 16-volt motor with a little piece of sandpaper stuck on the end. And that is so awesome for sanding into, tiny little nooks. I'm going to make one of those.
And I think everything on here is disposable lighter. I think that there's some paper, which looks like it might have been the box that all the lighters came in. But like the wheels, the wheels inside of the tires are the striker wheel from the lighter.
Right.
Maybe it's some electrical tape I'm not sure what the black for the wheels is, but like the seats are like heated and bent, kind of like the slider that adjusts the height of the lighter. Maybe it's the safety mechanism. Anyway, go watch the video. I think you're gonna love it.
I'm looking at that buffer thing. That is just a straight up motor in his hand. That is
really
a homemade tool doing the homemade work.
That is the hack of the day right there.
My first hack this week is Superb, a phased array ultrasonic 3D scanner from scratch. This is a long-running hack by Alex Toussaint. He says that he wouldn't have started this if he knew how to do electronics, because he would have realized how hard it was, and that would have kept him from doing it. He also didn't know any of the DSP necessary to do the beamforming, and that let him kind of approach it with a, hey, this might work. What if I try this effect? And then the thing that, of course, pulls it through is like double plus hacker spirit. He doesn't know what he's getting into. He gets in over his head, and that just forces him to push the project on through. And I just love that part of it. This is also a great write-up of what's going on with beamforming in general. If you've ever used sonar on like a little toy robot or something around your room, like one of those HR24 modules, those little pinger modules, you'll notice that like the angle of acceptance is something like 10 degrees, 15 degrees. The angle at which it receives bounces back from things is pretty wide, and you get all sorts of funny reflections in there. And if you try to sweep this across a scene, it's not entirely very informative. And here he's trying to do that not just in one direction sweep, but also in the other dimension to get a 3D distance scan. So it's a really hard problem. And his clever idea is then to, instead of just using one pinger, to make a two-dimensional array, a 10 by 10 grid of these pingers, and then use a little bit of DSP to figure out where the reflections are coming from. In this case, I guess he's beamforming on the transmitting side. So he's firing the pingers off in the right times with respect to each other to have the wavefronts add and subtract from each other and get a fairly tight little beam out of it. And not just thin in one dimension, but thin in the other dimension too. Like it's pointing little pokey fingers of sound out into the room. And when he hears the reflection come off those, he can be pretty sure that there's something in exactly that little square.
I really liked that this took inspiration from Charles Lohr's Wi-Fi visualization project, where he took a ESP something, 8266 or 32, I can't remember which one, and put an LED on it and then modified what the LED was doing based on like the RSSI signal of Wi-Fi, and then did like a long exposure. In this case, when the array was first being tested out, an ultrasonic receiver was attached to a microcontroller with an LED and changed the color of the LED based on what signal it was looking. And so then you could move that through space above the array and figure out what was happening with the I guess the beam forming or the beam guiding of that.
That beamforming angle is a little bit experimental. I think he'd never seen anyone do anything exactly like this before. And so he ended up having to write a computer simulation to figure out what the effect of this array would be and how wide it would make that beam. And so that's kind of what he's testing out by waving this colored LED around, is to figure out if it's actually working as well as it did in theory in practice. And lo and behold, it does, which is phenomenal. I mentioned at the very beginning of this, the electronic side, and you have to imagine 100 of these little piezo transducers packed in as tight as you possibly can. That's 100 of them you have to drive, and you have to drive them with fairly high voltage. So you can't just, drive them off the pins of your microcontroller. They all need 40 volts each, and he ends up buying some special shift registers that can handle this voltage and handle the kind of intense pinout here, and gets his first PCBs made. It's a lovely, lovely hack. The results are pretty stunning, I have to say. The fact that it all comes in at under $100 for a bill of materials for a few centimeter wide resolution 3D scanning beam forming sonar is kind of mind blowing.
I want to go back to a comment that you made at the beginning about, not knowing what you're getting yourself into. And I think this is such a great example of ignorance really being bliss, because it would be easy to have a strong background in this and kind of like know where the dragons are and not even get started. Like, it would just prevent you from doing that. And the other thing is, like, not knowing what is possible gets around you preventing yourself from making breakthroughs, right? So like,
Yeah.
some people would say this isn't possible to do the right way, like the right way in quotes. And that makes me think of hearing Jerry Ellsworth, who is founder of Tilt 5, I think it's called now. It was the Cast AR headset.
Right.
And I think she was on the Amp Hour podcast and was talking about the optics for it and how like the throw distance wasn't enough. And she had asked someone who was like a specialist in optics and like, you can't do it. And then she's like, there's got to be a way to do this. Ended up going and getting optics and putting it together and getting it to work for what she needed, which, might not be like the right way to go about designing optics, but it ended up happening. And, when you're talking about hacks, it's like making that
Make
accomplishment. Yeah. Get the thing to do the thing you want, even though that was never what someone planned for it.
Yeah. And there's great comments here so you should read through them. Alex shows up himself. There's a particularly nice back and forth with Comedicles, who mentions the kind of receiving transmitting symmetry here. And in this case, Alex is he's doing beamforming on the transmitter. He's got an array of transmitters, but then he only really needs one receiver. So he's just listening to the kind of aggregate 100 times echo coming back. And you could do it the other way. Alex makes the really great point that the receiving portion of it is analog, and that's necessarily more complicated electronics. And if you're going to duplicate something 100 times, you want to be duplicating the easy digital stuff. And I thought that was a great insight into kind of a hardcore problem like this.
I was really taken by an awesome robot art concept that Scanlime showed off this week. And Brian Cockfield wrote the article, Random Robot Makes Random Art. How to describe this? It is like you wiggle a felt tip pen all across a piece of paper, and after a half hour of wiggling, the density of these weird lines start to bring into focus a larger word or a larger image. It is based on the bristle-bot. So anybody that knows the origin of those, I want to give Evil Mad Scientist Laboratory credit for coming up with the bristle-bot. Does that sound right, Elliot?
I have no idea.
I think they did the first one.
Right vintage.
Yeah, so you could take the head of a toothbrush, or I guess a large brush. You have seen them very big, but let's go with the head of the toothbrush and cut the handle off, and then set it bristles down and hot glue like a tiny lipo cell and a pager motor, like the vibration motor from a pager on there. And then the oscillating weight and the kind of the springiness of the bristles would have this thing kind of like walk around in weird ways on your table. Now, what Scanlime has done is put 3 of these together with a pen in the center of it and then let them go. And the problem with that is it's still just going to be, like randomly around the page. And what you're trying to do is get this coagulation of entropy that actually comes up into something better. And the really killer part of this is there is one of those digital pencil tablets below this. So I would call it a Wacom tablet, but this is like a Huion, Huion brand. At any rate, it's the same concept. There's a coil of wire in between these 3 bristle bots, like that encircles the stylus itself, that gives position feedback to the computer. And then the computer has to figure out, how do I move these 3 vibration motors to kind of accomplish the goal that I'm going after?
Yeah, that's what I love about this, is the kind of closing the loop on the feedback, right? And so if you want to draw something with a bristle bot, even a 3-way controllable bristle bot, it's still kind of random. And so you really need to know where it's going and where it is, right? And that's what the tablet underneath does. And so then you just keep pinging the motors until it crosses back over your picture. And what I thought was really neat about that was because it's only kind of quasi-steerable, and when the bristle-bot's outside of the letters, it needs to go steer back into the letters. And what I liked most about this was the algorithm that does this, which kind of puts out a bunch of rays from the current position of the bristle-bot, sees which one crosses the most parts of the drawing that you need to blacken, and heads the bristle-bot in that direction. And so in that sense, it's actually a lot like those string art paintings. It's the string art where the thing can't steer in a straight line.
I enjoyed seeing the debugging frames that Scanline walks through. And it's definitely worth looking at that and studying it. You can, I think, learn a lot about this. Like, there's a control loop, but it's not like a 1-for-1. I can just tweak this value and X will happen. And so that's very interesting to me. Also, the second half of the video goes through a bunch of iterations on how to design the thing. And so you start looking at a Ninja Flex like triangle shape where the bristles are actually in the flex itself, and then you move to more of like just a one wire leg that has a stronger vibration motor attached to it, and you go to taking the pen out of it and really just having the nub of the pen going. So as far as like failing fast, getting a prototype out the door, like there's a lot to be learned from, and it is just enjoyable to follow along for the ride.
All right, next up is a hacky hack, reverse engineering an unknown microcontroller in e-ink displays. Serial hacker Dmitry Grinberg, who has got his hands on a bunch of e-ink displays and is starting to reverse engineer all of them. Along the way, he's got one in particular from Samsung where he had an earlier model that had a Marvel chip in it, and then this one that has a mystery chip. And a mystery chip to Dmitry is an invitation to do some heavy reverse engineering. Before getting started, Dmitry does his research, which is a really good thing to do. Remember this. I never do. I can never resist the temptation to start poking at it. He instead takes a picture of the board and does a Google search. And this actually gets him the CPU number off of the thing that he didn't know. And then armed with that CPU, he can do some searching. And through, finding the right lucky Korean website, ends up being able to purchase the in-circuit programmer for this unknown chip and figure out its little ISP header pin out. And that's just lovely. I love the idea of just take a picture of it and see if someone else has taken a picture of this thing and if Google can match the two circuit boards together for you.
I'm shocked that it matched these. How did it do that?
I think, actually, if you think about it, circuit boards have to be really easy for computer vision algorithms to match because they have really big, like square regular features and then a bunch of other little features. There's fiducials on it. It's meant to be seen by robot vision.
I'm just surprised that the search algorithm is robust enough to do like different orientations to adjust for the light levels. Like it seems like a difficult problem, but granted, I know nothing about how image search works.
I think it's pretty good. I'm surprised that there's the source material out there. I'm surprised that, someone else has taken pictures of this board, but of course there will be if people are trying to sell them. So...
Well, you always type like the model number and then tear down, right?
Exactly.
I always do that first, and then most of the time you don't find it. And in this case, it doesn't say model number teardown. It says how electronic price tag works, ? That's literally the title on Electrical Engineering Stack Exchange. But it's the images. Oh, that is the tip of the year, Elliot.
Isn't that crazy? Yeah. Well, this thing is full of these tips of the year then. So he finds out it's an 8051 chip. He's done a bunch of work on reversing 8051 chips. The next upcoming tip of the year is he figures out how to toggle one pin and then writes himself a little bit of a bit-banged serial output for this thing and then implements printf, and now he can start debugging the chip from the inside. He's got an OTA flash image for it, so he's got a binary that he can start looking for strings in and start debugging. And once he starts doing that, he runs into the watchdog timer. So he has to figure out the watchdog timer because the thing keeps rebooting itself every 2 seconds, which you can imagine would be lousy if you're trying to figure out how it works. He figures out the watchdog timer. He figures out the flash. He figures out the SPI interface. He figures out its internal temperature sensor, the I2C. This is a long post, and it's got a lot of heavy reverse engineering into it. He even manages to figure out its radio interface so that he can receive information from outside into this chip. So it's going to be a remotely controllable e-ink display pretty soon. That's awesome. There's way too much in this to digest. Scroll way down to the bottom, lessons for aspiring reverse engineers. And he starts off with the one that I never do. Spend a few hours before you start doing anything. A lot of his comments are about knowing how things work is of course important, but then also knowing how similar devices work is important, because chances are these engineers just copied other engineers and did the same thing over and over again. So without significant outside force, things will keep being designed as they always have been. Assume most designs are similar, and what you saw before is likely what you'll see again. Defaults are not changed most of the time. That was true here. Finally, you do have to just kind of experiment around, but you do have to have your experiments be guided by understanding the working principles of the device. So looking at other similar devices that you do have good information about can totally help enlighten you about the one that you're currently looking at. And the other thing I never do, take notes as you try to figure things out, because the branching tree of trying things will quickly become an unmanageable mess, and you'll forget things. And yeah, I should take better notes.
I really love the honeymoon period that comes after a piece of like community embraced hardware is released, because you see everyone grab this equipment and try to do something with it. And there's just a lot of clever things that come out about that. And of course, the honeymoon period that we're in right now is with the Raspberry Pi microcontroller, the RP2040. You see, even if these hacks aren't about that microcontroller, you just look on the breadboard and you're like, oh yeah, that's a Pico, a 2040 breakout board. As is the case with this one by Harry Waguna. It is the game of Snake, but the snake slithers.
Yeah, a wiggly snake on an OLED.
Yeah, so usually you just have a line, and every time you turn, you have like a 90-degree turn, and they call it the snake, and so the head of it's traveling along trying to eat a piece of fruit, which is just a dot that appears. If you end up hitting the side or you hit your own tail, then the game's over. And I think the length of the snake is what determines your score. But in this case, instead of just going from turn to turn, you get that zigzag back and forth pattern. And for me, it's just really clever to see that happen. But then you also wonder, if you've ever programmed this game, you're like, oh, how did they do that? Like what's the trick behind it? And in this case, it is just 4 sprites. So if you think about it, you can make a circle with 4 sprites. You'd have like an upper left would be an arc. I guess they'd all be an arc. It's just an arc turned 90 degrees from each one of them. And so depending on where the next slither is, you can just put in whichever arc segment you want. The difficulty comes when it's time to corner, and the cornering of this works pretty well. The only time it doesn't work and it's a little bit janky is, let's say your snake's going upward and the fruit is to the left of you. If you decide to turn left right when the arc goes like up and to the right, then you've got like a weird like backwards turn thing that has to happen in order to get there.
It's funny you mentioned that, because I was emailing back and forth with Hari about this and said, what's up with the wiggles there? What's the discontinuity? And he's like, look, this was a project to learn the new chip, and I was just having fun playing with it, and I was like, I'll try to make it awesomer, and I just couldn't get it done in, the few hours it took me to implement Snake on this thing. And so I just said, meh, good enough. So there's an open challenge left to the community here. If you can improve his Snake game, I bet it would actually look really cool.
Yeah, I think the problem is that a real snake can move the rest of its body when it needs to. But in the digital snake, once a segment has been laid down, it's immutable. At any rate, I think that this should be added. First of all, if you haven't written Snake for a microcontroller before, you got to do it. It's fun. Like, how do you store where the snake is right now? And then how do you decide when the tail moves? Because the snake only grows when you eat a fruit. So as the head moves, the tail has to move as well. So there's just like some really interesting challenges. It's a good Saturday afternoon, or depending on your skill, the month of May challenge. But now, having done that and ported it to a bunch of things and knowing where my bad programming is on that. Now I want to do this. I want this challenge because adding the illusion of wiggle motion is a cool piece for this.
I bet you can do it, Mike.
I'm on it.
And bringing up the rear, making minty fresh music with Markov chains, the After 8 step sequencer. This is a do-it-yourself synthesizer hack, and it's extremely do-it-yourself. Szczys Cat, who has done this, has never made, or I guess this is her third electronics project, out of which one or two maybe kind of didn't work out so well. So this kind of counts as her first successful electronics project, and it is extraordinarily successful. Basically, a sequencer is something that plays notes on a synthesizer in a row, usually. And so in this case, you have a row of 8 potentiometers, and you dial these up, and then where that potentiometer is determines what note plays when it goes through each of the 8 steps in a row. And that's kind of repetitive and not so super interesting. So she adds a second row of 8 steps to this thing, and then works on an algorithm to play them in a kind of musically interesting but quasi-random fashion. And so the idea is you have one line on the top with the 8 deterministic ones maybe playing a bass line, and then you have something going on underneath it that can afford to be a little bit random and where the variation's nice, like maybe a drum line. And she has examples of both of these in her video. You should absolutely check that out. The hardware interface here ends up being not super much more than the potentiometers, I guess also a rotary encoder with a button, and an Arduino. She then takes the data coming out of these, feeds them into her real computer, into Mac's MSP, and then has Max handle the synthesizer side of things, but then also the kind of pseudo-randomization Markov chain part on the random sequencer. And that's actually really clever here because I think this is early in Szczys Cat's microcontroller programming career, and she's not really handy with programming the Arduino, but this moves the kind of conceptually difficult stuff off to a computer where changing the way the algorithm works is as simple as tweaking some parameters here. And in Max is one of these visual programming languages, so it's, draw another line here. So she gets to spend a lot more time thinking about the high-level stuff because the low-level stuff is really just kind of the minimal hardware to get the job done. And I think that's actually really clever.
Now, if you want to kind of dig under the hood of what's going on with that Max MSP stuff, I would like to put in a little plug. I hadn't worked with it before, and I watched Guy DuPont's session from the 2020 Hackaday Remoticon, which is like online workshops. And I think that'll get you up to speed. You'll really like it.
And if you don't want to pay out for Max MSP, Pure Data is actually very similar and open source. Get yourself learned on Max and then take your knowledge over and apply it to Pure Data. The statistician in me has to quibble about her Markov chains. Usually Markov chains the idea is that if you have a bunch of different states, you can also have probabilities of going from one state to any other one. And so you make kind of this probability matrix going from the first step in your sequence to the second step, or the first step to the 8th step, or the first step to the 7th step. And you enumerate all these probabilities out, and then you just start rolling the dice and let it go. And that was what she wanted her synthesizer to do. But then inputting all of these 8x8, 64 probabilities was just kind of a pain. So she simplified it down to kind of the bare minimum, which is at any given step, you can go forward to the next step, repeat the step you're on, or go back to the previous step. So it kind of keeps this kind of linear sequencer-like structure, except adds the randomness about when you're going to take the next step and in which direction you're going to. So she ended up with this kind of like half flexible, half still sequencery blend here. And I think that actually worked extraordinarily well. And you can hear her background music running throughout the video. The video itself is just charming. She is figuring her way out through this stuff and is very honest about when she blows a potentiometer and when she has these just kind of major triumphs, and it's lovely to see.
First up on my list of quick hacks, when you want to use your wireless headphones, they are awesome until they're out of battery. So deciding to put a stop to that, Taylor Burley added an inductive charging coil to the part that goes over your head, the kind of strap there. And it's put there in order to mate with another one when you hang them up on a custom printed hook. It's a nice way to make sure that they never run out of juice. Next up, repurpose a monitor arm as a microscope mount. Captech has figured out how to 3D print an adapter that mates an AMScope with an articulated video monitor arm. This is nice because those arms are already made to carry something heavy, and those trinocular or binocular microscopes are kind of heavy. And what this adds to it is not just a solid mount, but it has the crank for like Z-axis, so like the height off of what you're looking through, so there is some adjustability once you get it in place. And last on my list, projecting moving images in air with lasers. This is the coolest thing. It is some research coming from Dan Smalley et al. And it's, let's say, this is a volumetric display. I've seen them before using ultrasonic transducers where you'd have like a piece of styrofoam. And I remember we had one that used like different color LEDs and it moved the styrofoam very fast and you could draw shapes on it and that was cool. This one is not ultrasonic, it's laser. So the particle that's floating in the air is actually being moved through 3D space by friggin' lasers, Elliot. And it's able to draw out shapes because it moves so fast and it does have some color elements to it. Is this going to become something in the future? I have no idea, but it's really cool to look at.
My first quick hack this week is a video from James Bruton actively balancing a robot with a gyroscope. If you take a heavy pancake and you put it on a motor, you've got a gyroscope. If you then try to turn this around using, in his case, a servo, it creates this reaction force, and you can use this to balance things. Gyros like this are used to stabilize satellites and boats at sea, and he is using this here to stabilize a robot that's going to roll on 2 wheels, and if he gets his way, maybe 1 wheel, by using kind of forward-backward IMU balancing in one direction and the gyro in the other to balance it on 1 wheel. That I want to see. Next up, Sandeep's tape cutter makes short work of through-hole resistor reels. You know how resistors come on those strips where they have 2 tape strips on either end? This is a machine that cuts through those tape strips with lovely overkill 2-stepper motor linkages that have those snap knife blades just held tightly in there, and it goes schnock and it cuts them off. Slightly terrifying, but very effective mechanism. Last up, WJSON Altus scanner captures Viewmaster discs as glorious 3D videos. If you know what a Viewmaster disc is, it's got a bunch of stereo images and they're on tiny little slides, basically. This is a machine that rotates those around, backlights them, automatically captures images of them. Viewmasters also add text on the front, and so it changes the lighting, takes a picture of the text, auto crops, auto rotates, does some OCR on the text. Still doesn't work out quite perfectly. There's one last stage of kind of manual intervention, and then it turns it into a video where you can watch the 3D Viewmaster as if it were back in the old days, except using Google Cardboard style goggles and a cell phone.
It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday writers. And you know, Elliot, I am always trying to up my game when it comes to the deep topics of physics. I'm glad that Bob Badley is here to help out with particle physics news coming out of CERN. The title of this article, Something's Up in Switzerland, explaining the B Meson news from the Large Hadron Collider. So first of all, is it Meson or Meson, do you think?
I think they're mesons, but I'm not 100%
Meson,
sure
yeah.
either.
All right, so obviously you know how deep my physics knowledge is if I don't even know how to say the word. But the gist of this one is a paper came out in March talking about recent experiments that predicted the occurrence of mesons, and then they detected actually about 15% fewer of them And the thing is, it's possible that this is nothing, or it's possible that this is something really momentous. So it's like Schrodinger's cat experiment, right? Like you just don't know. We're kind of in this theoretical void. And well, why can't we just go and test it? Well, the problem is the Large Hadron Collider is down for servicing until 2022. So there's going to be a bunch of speculation on this. However, Bob sums it up and brings a lot of clarity to it. There is about a 1 in 740 chance that this is a fluke. What do you think that means, Elliot? 1 in 740 chance that this is a fluke. Does that mean that this actually happened or that it didn't happen?
You know, if you run a bunch of kind of random experiments or experiments with a random component to them, and they happen one way a lot of the time, you can be pretty sure that there's an effect there. But if they happen kind of roughly 50-50, like you'd expect here with the meson decay, then it's hard to say whether it's exactly 50-50 or whether it's slightly more in one pile than the other pile without running the experiment a whole lot of times. And that's basically what they're doing here, is they're trying to say we see too many electrons and not enough muons decaying out of these mesons. What is the chance that this would have happened randomly by us just getting like some bad random dice rolls? And that's what that's what these, sigmas, these standard deviations are about measuring.
Right. And so I think one of the reasons I like this article so much is that Bob puts like just the right amount of wit into it. I think, Elliot, I came to you before publication. I was like, you got to read this. It's
funny.
Such an excited. Yeah, it's just wonderful. And Bob knows exactly like the amount of wit to put in there and where to do it. So it's almost like a carriage return on understanding. So he goes through like something that's a little bit heavy, and then he puts in this like punctuation mark that for me, it helps me commit it to memory and helps me like encapsulate it and think about it a little bit better. And like, just to explain, like, so why don't we get better, more easy to understand results from the Large Hadron Collider? And Bob says that the way that we're doing these experiments with this tool, it's like you have a cake and you're trying to figure out what that cake is made up of. And so you're throwing a grenade at the cake and analyzing the spray pattern to try and determine whether its frosting was buttercream or fondant. And like, for me, that's a really good, like, comical head above water moment for you to really think about the difficulty of getting the apparatus right, making sure that all the data has been captured accurately and that you're interpreting it accurately. Because there have been instances in the past, like in 2011, the superliminal neutrinos that turned out to be an improperly attached fiber optic cable. And there was a statistical fluke in 2015. So you do occasionally look at the data and look at the like crystal ball of science and see something that is not there. And so future testing and more thinking and better ways of analyzing turn those things up. And I think we're in the waiting room for that decision on this B Meson discovery.
And if you want to read a much harder to read physics paper about a similar physics experiment, The Mysterious Wobble of Muons by Moritz V. Sievers came out just a few days before. And this is a result coming out of Fermilab in Chicago that confirms a much older result coming out of Brookhaven. And this one is significantly more. This one's at 4.2 standard deviations away. So again, this is like 1 in 40,000 chance that it happened randomly and it was just a bad dice roll. But this one is going to get closer. Ironically, I think that is the simpler experiment, and it's also the one to look at for figuring out if there is some kind of new funny particle out there. Again, 4.2 standard deviations, not 5. So nobody's jumping up and down yet, but it's enough to be like, hey, let's look at this a little closer.
Well, let's give poor Moritz credit here. You said it was significantly harder to read. I would say it's a very well-written article that pulls no punches on the depth of the physics it's covering.
Oh, the physics is harder, and he doesn't shy away from explaining the physics. And actually, that is a real service. I actually really appreciate that. Boy, and speaking about understanding secret things that you didn't before. Gassing up, understanding the liquid fuel distribution network. Dan Maloney wrote this lovely article about, well, pipelines. We've all seen the Colonial Pipeline in the news recently because they had a cyber attack and it shut it down, causing gas price havoc along the east coast of America. And this, plus an episode where Dan was walking to his local gas station, which for him is in the middle of Idaho, nowhere near the ocean, had him thinking, how does the gas get here? And it can't be that those trucks drive all the way from the coast. And of course they don't. The oil, gas, and or diesel gets to you through a series of tubes that run underground. And this gave him a marvelous excuse to go looking into how this network works. I've always seen those like stations where they have those kind of inflatable things that look like they're silos with loose roofs that hold oil and gas that turn out to be called tank farms or oil terminals. And this is where the oil ends up after it comes through a pipeline. What had never struck me is that if you want to carry different things in the same pipeline, because pipelines are set up as common carriers, that is, the pipeline company is just carrying the liquid from point A to point B, and anyone who wants to load their fuel into it can pay them a fee and send it along down the line. They have this weird situation where there's like blobs of diesel floating down their pipe, followed by a blob of like lighter gasoline, followed by a blob of jet fuel, followed by. And there's this whole weird kind of scheduling and intermingling and intermixing of these blobs and keeping them separate and sorting them back out once the blob gets to the tank farm, sending some of it back to get re-refined. I mean, there's a lot of interesting detail in here, and it's, of course, it's gas in these quantities. It's big money. So it's a really interesting kind of window into this world of infrastructure running under your feet.
I didn't realize that they were using common pipes for the different products. And so that was a fascinating part of this. Yeah. And you know, if you think about it, it's kind of like those transition points are where some mixing will happen, but in general, it's pushing through the tube and staying segregated, I guess, from each different type. And so let's say they were sending out like a 90 octane with an 87 octane. Where it starts to mix, they would just shunt all that into the 87 octane because those are both the same products. But if you have, you know, a big difference, if you have a diesel and a jet fuel next to each other, then they actually shunt that into like a waste collection bin and it gets sent back to the refineries at some point. Now that, I'm wondering if that's done by tanker truck eventually, if you have like a waste tanker truck that goes all the way back, or if there's some kind of return to sender pipe.
They run that back up another pipe. Yeah.
Right. Yeah. So I just assumed these pipes were one way, you know, refinery to the distribution centers. And Dan talks about it might go to like one distribution center that then itself forwards it to other distribution centers. But, you know, they'll put them in these holding pods, but there's no money to be made by letting product sit in those pods. And so then the semi trucks that are the last mile of service, they come up and you fill them up with the different products and then they go out to the dispensary. A really interesting thing that caught my mind is that Dan said it takes about 5 days for a product to get from refineries in Houston to a depot in New York. And that made me go and look it up. It's about 1,627 miles. It happens over 5 days. And so if you figure out 5 days, 24 hours, it's moving at 13.5 miles per hour on average.
That's not very fast. You could ship that stuff by train.
You'd have to get it into the individual cars though, right? This way you have the valve system that's just putting things to where it needs to go. It's interesting. I like it. But when you start to talk about like a changeover from fossil fuels to renewables, like these pipelines had to be built, they have to be maintained. There's a cost to that. And I think that we don't, you know, always think about that when we talk about like needing to beef up the grid to use more operation. I mean, it would be one at the cost of the other. And so that's one of the reasons we see pushback in changing these major pieces of infrastructure from one system to a different one. Again, it's engineering hiding in plain sight, right? Like we just go to the pump and expect some diesel or some unleaded to come out when we need it. And then when it doesn't happen, like recently on the East Coast happened, then it's a real emergency for people. It's because these systems have been maintained so well that these emergencies are something that's unexpected to the average person. That's all the time we have for this episode of the Hackaday Podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you do something cool or you've seen something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking.
Did I steal your thunder on that?
I'm thunder free.
Teeny DeLorean, it's tiny, isn't it?
The word is tiny.
Yeah.
Next up, I'll cut that into something reasonable somehow.
Keep on clacking. You can hear your keyboard.
Phenomenon. Phenomena. Do.